Imagine 37 trillion cells, each one a microscopic universe of activity. Suddenly realizing that food has stopped arriving. No glucose flooding in from breakfast. No amino acids from lunch. No fatty acids from dinner. Just silence. For the first time in perhaps years, your cells must face a question they've forgotten how to ask. What happens now? Most people never think about this moment, but it's happening right now in someone's body. A cellular alarm spreading through tissues like whispers in a dark theater. The panic is real, and it begins within hours. In the first 12 hours without food, your cells scramble. They reach for the easiest fuel source, glycogen, stored glucose packed away in your liver and muscles like emergency rations in a bunker. The liver releases this stored energy into the bloodstream, keeping your brain and organs running smoothly. But here's what most people don't realize. Those reserves are limited. An average adult stores only enough glycogen to last about 24 hours. And once it's gone, the body faces a crisis. Cortisol spikes, adrenaline surges. These stress hormones aren't signs of weakness. They're emergency protocols, ancient signals telling every cell to prepare for survival mode. Your heart rate may increase slightly. Your senses sharpen. The body isn't shutting down. It's activating. Then, somewhere between hour 12 and hour 24, something extraordinary begins. The panic subsides. The noise quiets. Your cells stop searching for external fuel and start looking inward. Backup systems that have been dormant for months, maybe years, flicker to life. Fat stores, long ignored, suddenly become valuable currency. The liver begins converting fatty acids into ketones, molecules your brain can use when glucose disappears. It's like watching a city switch from fossil fuels to solar power, seamless if the infrastructure remembers how to do it. And your cells do remember. They've done this for millennia. This isn't starvation. It's adaptation. Our ancestors' cells knew this rhythm intimately. They fasted not by choice, but by necessity. Between hunts, between harvests, between moments of abundance. Modern cells have grown comfortable, fed every few hours, never tested, never challenged. But the ancient programming remains, buried in your DNA, waiting. Fasting for 72 hours isn't about deprivation. It's about reminding your cells of what they've always known how to do. But what happens when glucose runs out completely? When your cells realize this isn't a brief delay, but a full shutdown of external fuel, that's when the real transformation begins. And it starts at the deepest level imaginable. Somewhere between hour 24 and hour 36, your body crosses a threshold. Insulin, the hormone that's been directing traffic in your bloodstream for years, drops to its baseline level. Glucagon, its opposite, rises steadily. This isn't a gentle transition. It's the moment your cells stop waiting and start adapting. The rules of energy production are being rewritten in real time, and most people have no idea it's happening inside them right now. The liver becomes a factory of transformation. Fat molecules, stored for exactly this purpose, are broken down and converted into 3 types of ketone bodies: beta-hydroxybutyrate, acetoacetate, and acetone. These aren't inferior fuels. They're premium alternatives, compact energy packages that your brain can use just as efficiently as glucose, sometimes even better. Think of it as switching from gasoline to clean electric power. The engine runs smoother, produces less waste, and performs with surprising efficiency. Within 36 hours, ketone levels in your blood can rise from nearly 0 to several millimoles per liter, enough to fuel your most energy-hungry organ, your brain. But here's what's truly fascinating. Your mitochondria, those tiny power plants inside every cell, begin to adapt. When burning ketones instead of glucose, they produce fewer free radicals, those unstable molecules that damage cellular structures over time. Energy production becomes cleaner, more efficient. Scientists measure this through ATP generation, the universal energy currency of cells, and the numbers are remarkable. Cells running on ketones often produce the same amount of energy with less oxidative stress. It's like upgrading from a smoky old factory to a modern solar-powered facility. And then there's the hunger paradox, something that confuses nearly everyone who tries extended fasting. After 36 hours, hunger often decreases rather than increases. Ghrelin, the hormone that makes your stomach growl, stabilizes. Ketones themselves suppress appetite signals in the brain. Your body isn't starving. It's strategizing, conserving energy by reducing the urge to hunt for food it doesn't immediately need. The desperation of the first day fades into something unexpected. Calm. Within this window, other signs emerge. Mental fog lifts. Energy levels stabilize without the crashes that come from eating. Blood tests would reveal dropping levels of C-reactive protein, a marker of inflammation throughout the body. Your cells aren't just surviving without food. They're beginning to thrive in ways that constant eating never allowed. But this metabolic revolution is only the beginning. Deeper within your cells, an even more profound process is about to reach its peak. Between hour 48 and hour 72, something remarkable reaches its peak inside every cell in your body. It's called autophagy, a word that literally means self-eating. Before you recoil at the term, understand what's really happening. Your cells aren't destroying themselves. They're cleaning house, breaking down damaged parts, and recycling them into new, functional components. This process won a Nobel Prize in 2016 when Japanese scientist Yoshinori Ohsumi revealed its intricate mechanics to the world. It's not just cellular maintenance, it's cellular survival. Here's how it works. Inside each cell are tiny structures called lysosomes, essentially recycling centers filled with enzymes. When autophagy activates, these lysosomes identify and engulf damaged proteins, worn-out mitochondria, and misfolded protein chains that have been cluttering your cellular machinery. Think of it like a recycling plant that doesn't just throw away broken parts, but melts them down and rebuilds them into useful materials. Two important cellular pathways control this process. When you eat, a protein called mTOR stays active, telling cells to grow and build. When you fast, mTOR shuts down, and another pathway called AMPK turns on, triggering the cleanup crew. What exactly gets cleaned during these critical hours? Damaged organelles, the tiny organs inside cells that have stopped working properly. Protein aggregates, sticky clumps linked to diseases like Alzheimer's and Parkinson's. Tau proteins and amyloid plaques, the molecular garbage associated with brain degeneration. All of this cellular debris accumulates naturally from normal metabolism, from breathing, from simply being alive. But when you eat constantly, your cells never get the signal to clean it up. Fasting flips that switch. There's also a darker reason why autophagy matters. It removes cells that have started to go wrong, precancerous cells that haven't fully transformed but are heading in a dangerous direction. Fasting creates an environment where healthy cells can adapt and damaged cells cannot. Research shows that abnormal cells, unable to switch to ketone metabolism, essentially starve while normal cells thrive. It's not a guarantee against disease, but it's a form of cellular quality control that happens naturally when given the chance. The truly astonishing part? You feel almost nothing. No dramatic moment announces that autophagy has peaked. No alarm sounds when a damaged mitochondrion gets recycled. Yet this invisible miracle is occurring everywhere, in your brain cells, your liver, your muscles, your heart. Every tissue in your body is performing microscopic surgery on itself, cutting away what's broken and rebuilding what's essential. And it's happening right now, silently, perfectly, without you having to think about it at all. Fasting isn't just about what stops happening in your cells. It's about what begins. Scientists call it hormesis, a concept borrowed from toxicology that describes how temporary stress makes living systems stronger. Think of it like exercise. Lifting weights damages muscle fibers, and that damage triggers growth and adaptation. Fasting works the same way at the cellular level. The mild stress of going without food activates ancient defense mechanisms, proteins called heat shock proteins and sirtuins, particularly SIRT-T1 and SIRT-3, that protect cells from damage and extend their functional lifespan. Your cells aren't suffering, they're training. One of the most dramatic changes happens with human growth hormone. By hour 72, levels can increase up to 5 times higher than normal. This isn't random. When the body senses extended fasting, it floods your system with growth hormone to protect lean muscle tissue from being broken down for energy. At the same time, it accelerates fat burning, ensuring your body pulls fuel from fat stores rather than cannibalizing muscle. It's an elegant survival mechanism, one that kept our ancestors strong even during food scarcity. The hormone surge also promotes cellular repair throughout the body, helping damaged tissues regenerate faster than they would with constant eating. But perhaps the most exciting discovery comes from research at the University of Southern California. Scientists found that prolonged fasting triggers stem cell regeneration, particularly in the immune system. Old, worn-out immune cells die off during the fast, and when you begin eating again, new immune cells generate from stem cells that were dormant. It's like rebooting your body's defense system, replacing outdated software with a fresh installation. The immune system literally becomes younger at a cellular level. Inflammation, that persistent fire burning in modern bodies, begins to cool. Molecules called cytokines, which signal inflammation throughout the body, drop significantly. Oxidative stress, the cellular equivalent of rust forming on metal, decreases as well. Blood markers like interleukin-6 and tumor necrosis factor alpha, fancy names for inflammation signals, decline measurably within 72 hours. The result is less pain, less swelling, and cells that can finally focus on growth instead of constant damage control. But here's the catch, and it's crucial. Not everyone should fast for 72 hours. People with eating disorders risk triggering dangerous behaviors. Pregnant women need constant nutrition for developing babies. Diabetics on medication could experience dangerous blood sugar drops. Those with hormonal imbalances, particularly women with thyroid issues or menstrual irregularities, may find fasting worsens their symptoms rather than helps. The cellular benefits are real, but they come with responsibility. Stress that strengthens one person's cells might overwhelm another's. Understanding your own biology matters as much as understanding the science itself. Your brain cells respond to fasting in ways that seem almost too good to be true. Within 72 hours, levels of brain-derived neurotrophic factor, or BDNF, surge dramatically. Think of BDNF as fertilizer for neurons. It stimulates the growth of new brain cells and strengthens the connections between existing ones, particularly in the hippocampus, the brain's memory center. When BDNF increases, learning becomes easier, memories form more readily, and existing neural pathways become more resilient against age-related decline. But why would the brain get stronger when food disappears? The answer lies in evolution. Our hungry ancestors needed sharp minds to find their next meal. Mental fog during famine meant death. So the body evolved to enhance cognitive function precisely when food became scarce. The mitochondria inside brain cells, those microscopic power plants, become remarkably more efficient during extended fasting. Brain cells typically run on glucose, which provides quick energy but creates unstable blood sugar levels. Ketones, by contrast, offer steady, consistent fuel without the crashes. When neurons burn ketones, they produce energy more smoothly, which translates directly into stable focus and concentration. There are no mid-afternoon slumps, No brain fog after meals, just sustained mental clarity. It's the difference between flickering candlelight and a steady electric bulb. Fasting also reduces oxidative damage to neurons, the kind of wear and tear that accumulates over decades. Research shows that extended fasting helps clear beta amyloid proteins, the sticky plaques associated with Alzheimer's disease, from brain tissue. Neuroinflammation, chronic low-level inflammation in the brain linked to depression and cognitive decline, decreases significantly. In essence, your brain cells are protecting their own future while improving their present performance. Every neuron gets a chance to repair damage that constant eating never allows time to address. But the experience isn't universally positive. Cells in your gut-brain axis, the communication highway between your digestive system and your mind, respond to fasting as well. Reduced inflammation in the gut affects how neurotransmitters are produced, which directly influences mood. Some people experience euphoria around hour 72 as endorphins rise and ketones stabilize. Others feel irritable, anxious, or emotionally raw as their bodies transition between fuel sources. Both reactions are normal. Both are temporary. The key is understanding that discomfort during the first 48 hours doesn't predict how you'll feel at hour 72. Here's the truth most people don't expect. The first 2 days can bring mental fog, difficulty concentrating, and slower reaction times. But by hour 72, many people report the opposite. Laser focus, creative breakthroughs, and mental energy they haven't felt in years. Your brain cells are adapting to a fuel source they haven't relied on regularly, perhaps in decades. The transition takes time, but the destination is worth the journey. 72 hours isn't arbitrary. It's the point where autophagy reaches peak activity, where ketosis stabilizes completely, and where cellular repair mechanisms hit maximum efficiency. Science chose this timeline not by convenience, but by observation. By the time 3 days pass without food, you've proven something profound to your cells. They can still do what evolution designed them for. This isn't punishment. It's a conversation with your biology, reminding 37 trillion cells that they remember an older, stronger way to survive. The long-term implications extend far beyond 3 days. Regular fasting has been shown to affect cellular age markers in remarkable ways. Telomeres, the protective caps on the ends of your DNA strands that shorten with age, may be preserved longer in people who practice intermittent or extended fasting. Cellular senescence, the process where cells stop dividing and start accumulating like biological garbage, slows down. Mitochondrial biogenesis, the creation of new power plants inside cells, increases. Studies in mice have shown lifespan extensions of up to 40% with regular fasting protocols. Human studies suggest similar benefits: reduced markers of aging, lower rates of age-related disease, and cells that function as if they belong to someone years younger. But how you break the fast matters enormously. After 72 hours, your cells are primed to absorb nutrients with extraordinary efficiency. Your digestive system has been resting, and shocking it with heavy, processed foods can cause discomfort or worse. The traditional approach, used across cultures for centuries, is gentle reintroduction. Bone broth provides easily absorbed minerals and amino acids. Light fruits offer simple sugars without overwhelming insulin. Cooked vegetables deliver nutrients without demanding intense digestion. Think of it as waking someone gently, rather than sounding an alarm. Your cells need time to shift from breakdown mode back to building mode. The benefits are clearest for certain people. Those with insulin resistance find their cells regain sensitivity. People struggling with chronic inflammation see measurable improvements. Anyone seeking a cellular reset, a biological reboot, can experience profound changes. But the warnings from earlier still stand. Those with eating disorders, pregnant women, diabetics on medication, and people with hormone imbalances should approach extended fasting with extreme caution or avoid it entirely. If your cells could speak after 72 hours, they wouldn't complain about deprivation. They'd describe the cleaning, the efficiency, the remembering of ancient rhythms. They'd tell you about damaged parts recycled, inflammation cooled, and energy systems restored. But they'd also remind you that balance matters more than extremes. 72 hours can change your cells profoundly, but respecting the process, understanding your unique biology, and approaching fasting with both curiosity and caution is what keeps them healthy for life.